So we're going to carry on from where we got to at the end of last lesson, and we were looking at sequences, and we had pattern sequences, and then we moved on to number sequences. And we ended last lesson by looking at, we had 2n, 3n, 7n and 5n. Casper, can you remember what they were? Another way of saying what 2n, 3n, 7n and 5n were?
They were the...
Absolutely, so we 2 times, if we started we'd have 2 times 1, then we could say that n was 2, or n was 3, or n was 4. And therefore, what am I creating by doing this? What sequence of numbers am I creating by doing that? Joanna? I'm creating the 2 times table, aren't I? Because I could carry on, I could have 5, 6, 7, 8, 9, 10 and so on, and I would create all the numbers in the 2 times table. Now when you say the 2 times table, normally you'd go up to 12 times 2, but of course we could carry on, couldn't we, forever, and as you say, infinitely. So 2n will create the 2 times table. So 3n, Charlotte, will create what? The 3 times table, and 7n, Lauren, will create 7 times table, and 5n will create what? 5 times table. Good. Go on, Fred, come on. Do you sit yourself down there? So, we're going to create the different times tables by writing it as 2n, 3n, 7n and 5n, or whatever we wanted, 4n, 6n, anything at all. If we wrote it like that, we would create the different times tables. So, let's have a look at this. So if I look at this sequence that I've got here, 2, 4, 6, 8, we know that that's the 2 times table. And we know that we can write it as 2 times 1, 2 times 2 and so on. Have a look at this one here. This is a slightly different sequence, isn't it? 3, 5, 7, 9. But what does it have in common with the 2 times table there, Fred?
It goes up in 2s.
It goes up in 2s, doesn't it? That goes up in 2s and so does that one. So it has in common that it also goes up in 2s. But what is different about this one to this one?
Yeah. The top one starts with a 2 and the bottom one starts with a 3.
Excellent. So the top one starts with a 2 and the bottom one starts with a 3. So instead of saying 2, 4, 6, 8, I'm going 3, 5, 7, 9. So instead of saying 2n, how could I adjust my 2n, or how could I add to my 2n, to generate something that would tell me about 3, 5, 7, 9?
Be 2 plus 1? Or?
Good. 2n plus 1. Because my 2 times table starts at 2, but my new sequence starts at 3, which is 1 more than 2. So 2n creates the 2 times table. 2n plus 1 creates the 2 times table, but 1 further on. Does that make sense? Yeah? Good. Okay, so I'm going to give you another sequence on here. So let's say we have 4, 8, 12, 16, 20. And that could go on and on and on, couldn't it? So Fred, what have I written up here?
The 4 times table.
I've written up the 4 times table. Good. And how else can I write the 4 times table? Instead of writing out all those numbers, what short way have we worked out to write the 4 times table? Fred?
4n.
4n. Happy with that, Charlotte, as well? Yeah? Okay. So I can, instead of saying 4, 8, 12, 16, 20, I could just say 4n, and we would know that that was the 4 times table, because that n could be any number at all. But what about this sequence then? And of course that could carry on. Harini, sorry.
Add 4.
Add 4. So it is like the 4 times table, isn't it? Because it's still going up in 4s. So it must be based on my 4 times table. But how many more than my 4 times table is it?
2.
Add 2. Yes? So it's based on my 4 times table, but it's 2 further on. So now I can write 4n plus 2, and that's a way of describing that sequence. Make sense? Yeah? Okay. So let's do one more, and then you're going to try a couple yourselves. So what about if I start with this one? What have I written there? Mirana, what have I written there?
The 3 times table.
It's the 3 times table, isn't it? And how can I write the 3 times table in short form?
3n.
3n, good, because I know that the 3 times table is 3 times 1, 3 times 2, and so on. So what about this one?
Would you do 3n minus 1?
Brilliant. 3n minus 1. Can you explain why?
Because you're going down a number.
Right, yes.
Still adding 3.
Excellent. I've gone down a number from the 3, but I'm still adding 3 each time. So I'm still doing plus 3, plus 3, plus 3. So I know it's based on that 3 times table, but it starts 1 less. So I need to take off 1. Everyone happy with that? Right. So I'm going to put a couple on the board, and I want you to see if you can work out how to write them. Now, the only thing I'm not going to do is give you the start times table. You're going to have to work that out for yourself. So let's just think about that. If I gave you this. Now, that's clearly not the numbers in any times table we know, but do we know what times table that's based upon? Excellent. Irini, how do you feel? Can you see what times table that's based upon? Which one is it? Which times table is that? No, it's not, because the 6 times table goes 6, 12, 8. No, not quite. Let's see if somebody can tell you, and then see if you can see where they've got that from. Charlotte?
5n plus 1.
Right, it's based on the 5 times table. Well done. How do you know it's based on the 5 times table, Charlotte?
Because it goes up in 6 and 11, and then if you subtract 1, then it's 5, 10.
Right. So it's going 6 to 11, so I know I'm going up in 5s. So if I'm going up in 5s, that must be based on the 5 times table, mustn't it? Because we know that the 5 times table goes up in 5s. Yeah? So you then said to me, Charlotte, you said 5n plus 1, didn't you?
Yeah.
And why did you say 5n plus 1?
Because if you plus 1 to 5, it makes it.
Yes, 5 times table starts at 5. My sequence starts at 6, so I need to add on 1. Is everyone else going to say that as well? Excellent. Right. These are the ones for you to try. Harini, are you happy with that now, yeah? Okay. So let's give you a few to try. So, number 1, see if you can write down this one. Right, try those 5 for me. Times table. So what do I know I can write first of all?
3n.
Good, 3n, because that's the way the 3 times table works. But it doesn't start at 3, does it? So what do I need to do?
Minus 1.
Ooh. My 3 times table starts at 3, but this one starts at 8.
Oh, plus 1.
Plus
1.
plus 1 would get me to 4, wouldn't it? Because I want to get to 8.
It's 5.
Good girl, plus 5. 3 times table starts at 3. My sequence starts 5 numbers further on. So I need to do 3n plus 5. Everyone happy with that? Yes? Fred, can you tell me the second one?
4n minus 3.
4n minus 3. Can you explain how you know that to be correct, which it is?
Because it's going up in 4s,
Right?
but it's but you can see that it's the 4 times table. If you look at the 4 times table, it's 3 numbers down.
Right,
So
good.
it's 3 numbers.
The 4 times table, if I was to write it above it, goes 4, 8, 12, 16. So I can see that I'm 3 numbers down, 3 numbers subtracted from that, so 4n minus 3. Everyone happy with that? Matthew, what about the third one?
Well, the times table was 7.
Good.
So up in 7.
Yeah.
It would be 7n minus 1.
7n minus 1. Excellent, well done. Yes, it's going up in 7, so it must be the 7 times table, so it's 7n. But my 7 times table starts at 7, this starts at 6, so I take 1 off. Casper, can you do number 4 for me,
Yeah.
please?
So it's the 2 times table.
Good.
So it's 2n plus 5.
Excellent. 2n plus 5. We can see it's going up in 2, so it must be the 2 times table, but it doesn't start at 2, it starts at 7, so we have to add 5 to it. Lauren, what about this next one?
I'm not sure about that.
Okay, so how do we start to see if we can sort it out? What do we need to do first of all? What have I done?
Find out what times table is.
Yes, and how do I do that?
Finding the difference.
Good, finding the difference. What's the difference between 3 and 8?
5.
Good, so that goes up in 5, and we just need to check, does the next difference 5 as well?
Yeah.
Right, so what times table is this based on?
5.
So what can I know, what do I know that I can write?
5n.
5n, good. Now, the 5 times table, if I write it above, starts at 5, 10, 15, 20, 25. So what do I see is the difference between starting at 5 and here? What do I need to do? Instead of starting at 5, I want to start at 3. So what do I need to do to find n?
Plus 2. Minus.
Which one?
1.
Minus. 5 times table, which this is, starts at 5, but this starts at 3, so I need to take away 2. Okay, happy with that? Everyone happy with that? Casper, you want to do the one on the board from here there?
Yeah.
Good. Right, let me just rub this out, and then I can put the answers up here so you can see them. Right, so that first one, which times table is it based on?
The 4 times table.
So I can write,
4n.
good,
And then, because it is the 4 times table, it's minus 1 because it's 3. And
Yes.
4.
absolutely right. 4 times table because it's going up in 4s. But the 4 times table starts at 4, this starts 1 less than that at 3, so I need to take away 1. Everyone happy?
Yeah.
Number 2, Irana.
5n plus 1.
Very good, 5n plus 1. Everyone happy with that? The difference between those is 5, so I know it's based on the 5 times table, so I can write 5n. But my 5 times table starts at 5, this starts at 1 more than that, so I need to add 1. Dorel, can you do number 3 for me, please?
6n plus 2.
Excellent, 6n plus 2. The difference is 6, so I know it's based on the 6 times table, so I can write 6n, but my 6 times table starts at 6, this starts at 8, so I know I need to add 2. Last one on this slide here. Yes, go on, you tell me.
4n plus minus 2.
4n minus 2. Good. Is everyone clear about how these are working, yes? Do you know that this is something that you might get asked in the GCSE paper as well? It's not just Year 8 maths, this is GCSE paper stuff as well. So, let's just have a little think about what we've been writing here. And we're just going to have a look at a little bit of terminology, and then you're going to do something for yourself. So let's take that top one. 3, 7, 11, 15, 19. And we said it was 4n minus 1. Now, Can you see at the title at the top of that slide there? It says finding the nth term formula. Right. We need to explain some of those things, what that means. Now, in this sequence that I've got here, this is my first term, number 3. And this is my second term. This is my third term. And so on and so on. Fourth term. Fifth term. Now, how many terms did we say I had altogether?
Infinite.
We said, right, we had an infinite number of terms. So it goes 1, 2, 3, 4, 5. And I could keep on going forever to a number that never ends, that never finishes. So I'm just going to call it n, because I can't actually write a number down, can I? But I know that n stands for any number I want it to stand for. So if that's my fifth term, how would I describe this one? First term, second, third, fourth, fifth. The last term is n, so what would I call it?
The nth.
Excellent. The nth term. Now that n could be any number I like. But that's what it is, isn't it? It's the nth term. If that's the first, the second, the third, this one must be the nth term. And it says finding the nth term formula. Now, that means that I'm finding a formula that will describe this particular sequence, and only this sequence, and I'm going to write it in this form with an n in it, rather than lots and lots of numbers. That's what that means. Now, it says formula. Does anybody know what a formula is? How you would describe a formula? Yeah.
Would it be like a rule of like how to answer that certain question?
Very good. It's a rule for answering a question, isn't it? And formulas, we get all sorts of formulas. You might know the one for finding the area of a circle. Do you know that one? Or the area of a triangle. Do you know the formula for the area of a triangle? How do you find the area of a triangle?
Half times base times height.
Excellent. Half base times height equals area of a triangle. That's a formula. That tells me the rule for finding this. But I've put in there that it's an nth term formula. So I'm saying it's the rule for finding the numbers in this sequence. Yes? Now, normally a formula would have an equal sign in it, wouldn't it? And this one doesn't at the moment. But I can make it have one in it by doing that. The terms of this sequence equal, or can be found, by doing 4n minus 1. Does that make sense? So that's what that means, finding the nth term formula. It means writing this sequence using a formula, a rule, rather than writing out all those numbers. And do you remember at the beginning, we looked at those patterns and I asked you to write down a rule. You said add an arrow on each time. That was your formula for doing that. Now this is my formula for finding a sequence. So, what we're now going to do is go backwards a little bit. So instead of finding the formula from the sequence, I'm going to give you the formula and you're going to find the sequence. Okay? So we're going to go back the other way to check that we understand how this is constructed. Is everybody happy with going in this direction from the sequence to these formulas? Yes? Happy with that? Right. So, let's go back the other way. So I'm going to give you a formula now. 3n plus 2. And I want you to have a little think and see if you can find for me the first 5 numbers that would be in that sequence. So the terms of my sequence come from doing 3n plus 2. So what would be the first, the second, the third, the fourth? Should we say 4, 5? Let's do 5. What would be the first, second, third, fourth, and fifth terms in that sequence. Do you want to write them on your board for me first? And then we'll see if everyone can get it down. That's looking good so far. Yeah, I can see that. That's good. Excellent. Well done. Hey, very good. Yeah, good. Yeah, put your hands down for me because I think you've all got there. Charlotte, what did you write down for the first term?
5,
And then the next one?
8, 11, 14, 17.
Very good. And how did you know that the first one was 5?
I did 3 times 1.
Yes.
Away plus added 2.
Very good. 3 times 1 plus 2. Fred, how did you know that the second one was going to be 8?
5 plus 3.
Yes, because in fact, because you know this is based on the 3 times table, you could just say, well, I know that the difference has to be 3, so the next one will be 8. Yeah? How did you get the third one in the sequence, Matthew?
You just add on 3, it's the same thing again.
Just keep going, don't you? Keep adding on 3. What about if I asked you for the 10th term in that sequence? Karini, what would you do?
3 times 10 plus 2.
Excellent. 3 times 10 plus 2. Is that the only way to find the 10th term in the sequence? Is there another way to do it? Yolanda, how do you do it?
Could carry on how we did it, with like working out each one. But that would be a bit slow than doing
Very good. You could do it exactly as you just said. We could say the 6th, the 7th, the 8th, the 9th, the 10th. Just keep on adding 3 and we'd have got there. But you picked the simpler method, didn't you? The quicker method. So what about if I wanted the 50th term in that sequence? What about the 50th? Yeah?
Would you do 3 times 50 plus 2?
Brilliant. 3 times 50 plus 2. Make sense? Casper?
Would it be 170? Oh yeah.
It would be 3 times 50.
152.
That's better. 152. So what's this one then? 32. Good. Yes. All right. Okay. We're going to do a little bit more of that, a little bit more of sequences. So what I want you to do now is I want you to find 2 sequences for yourself that you haven't, we haven't actually done yet. So you're going to make up 2 sequences of your own. You're going to write down the first 6 numbers in the sequence. You're going to write down the rule in words, and you're going to write down the formula for the rule. T equals whatever it equals. Okay? Is everyone clear? I'll give you an example, or are you all clear what you know what you're doing? Okay? Right, so I want 2 sequences. I want the first 6 numbers, I want the rule in words, and then I want the formula. So the rule in words for 3n plus 2 would be multiplied by 3 and add 2. Okay? So 2 sequences, try and make them different to the ones that we've done. I will put an example on the board, and if you find that too easy, which you might by now, you can try my extension, which is to try sequences where the numbers get smaller instead of bigger, and or try some sequences where the numbers start with negatives. So do 2 normal ones, and then see if you can extend it a little bit. Words for 3n plus 2 would be multiplied by 3 and add 2. Okay? So 2 sequences, try and make them different to the ones that we've done. I will put an example on the board, and if you find that too easy, which you might by now, you can try my extension, which is to try sequences where the numbers get smaller instead of bigger, and or try some sequences where the numbers start with negatives. So do 2 normal ones, and then see if you can extend it a little bit. Extensions. Fred, do you want to give me your first one?
15, 27, 39, 51, 63 and 75.
Lovely. And what did you say that was the formula for that, well, the rule for that one?
12n plus 3.
12n plus 3. So the terms of the sequence are 12n plus 3. Okay, good. The rule in words to get from one term to the other?
Add 12.
Add 12. Now, we have to be a little bit more precise now, because we can be, because we understand what's going on. If I had a thing that said add 12, and I didn't see what you've got there, I could start at 1 and go 13, 25, 37, and so on. And that would be right. I'd added 12 each time. But what do you need to add to your rule in words to make it precisely this sequence rather than this one or any other?
Add 15 to 12. Add 12 to 15.
Right, yes. So I need to put the start point in, don't I? Add 12, starting at 15. Otherwise, it could be any sequence that adds 12. But that now is precisely this one. Well done, Fred, you're absolutely right. On all counts there. Good. So let's take another one. Irana, can you give me your first one or whichever one you want?
Do you want me to give you the...
Give me the numbers first, yes, in the sequence.
10, 9, 28, 37, 46, 55.
Lovely. And what did you come up with for your formula for that?
9n plus 1.
Excellent. And what would your rule be in words?
Add 9.
And can you extend that rule to make it precisely your sequence rather than any sequence that adds 9?
Starting at 10.
Excellent. Starting at 10. Well done. Matthew, yours. Give me one of yours, please.
5, 13, 21, 29, and 37.
And 37. Your formula?
8 and minus 3.
Good. And in words?
Plus 8. Add 8 to 5.
Yeah, add 8 starting at 5. Well done. Good. Everyone happy with those? Right, who managed to have a go at some negatives or some getting smaller ones? Right, well let's have a try at a couple of those then. And see what you came up with there. So let's start, anybody do some where the numbers got smaller? Alright, Casper, do you want to give me your first one?
Yeah. Minus 52.5.
Go on then.
Minus 50.
Oh, okay. Yeah.
Minus 47.5.
Yeah.
Minus 45.5.
Minus 45, I think.
Oh yeah.
Yeah.
Minus 45.
And
And minus 42.5.
well done. Right. Okay. So you weren't making life easy, were you? Go on then. What's your formula?
I never wrote that down.
Ah, right. Okay. So we've started with that. So what's the rule in words?
Start at 52.5
Yeah.
and go down by 2.5.
Are you sure we're going down by 2.5?
And then going up by
So
2.5.
we're adding
Yeah.
2.5. Right. Okay. So if we're adding 2.5, what times table is this based on? Nominally. Not that we do have this one, but if we go up in 2s, we're based on the 2 times table. If we
Yeah.
go up in 3s, we're based on the 3. So if we go up in 2.5s,
2.5.
so isn't it 2.5n?
Yeah.
But our 2.5 times table starts at 2.5 and we want to start at minus 52.5. So how do I get from there to there? Fred, you want to tell me?
Wouldn't it be minus 55?
Yes, Fred, it would. Minus 55. It's exactly the same rule, isn't it? We've done exactly the same thing. We've said, right, what are we adding on each time? Well, we're adding on 2.5. So it must be the 2.5 times table, if such a thing were to exist. It'd be great if we don't have to learn it. But our 2.5 times table starts there. It goes 2.5, 5, 7.5, 10. But we want to start down there, so we need to take away 55 to get to that start point. Yeah? Good sequence, right. Okay, someone else who has a one with negative numbers in it.
I do.
You do? Go on then, tell me what they are.
Let's go, it's shrinking and it has negative numbers.
Okay, go.
So 5, 2, minus 1, minus 4, minus 7, minus 10.
Right, everyone happy with that? Right, now then. What do I need to do to find out the formula for this? What's the first thing I need to do?
I'll probably do 5 minus 2.
Yeah, and what do you get?
3n.
So we are, well let's just think, we're going down, aren't we? So it's going down in threes, we're subtracting 3 each time. And that's happening each time. So, which times table is this based on?
Minus 3n.
It's based on the minus 3 times table. Again, it's not a times table we ever need to learn, but it is nonetheless there. So it's, as you say, minus 3n. But my minus 3 times table starts at minus 3 and this starts at 5, so what do I need to do? Go on.
I'll add 8.
Add 8. Same rule, isn't it? We're doing the same things every time. Even though the numbers have got actually quite a bit more complex now, the rule that we've been putting together still works. Still gives us exactly the right thing. Because if I wanted the 10th term in that sequence, what would I need to do, Charlotte, to find the 10th term in this sequence?
You do minus 3n
And what would n be if I wanted the 10th term?
of times 10
Good. Minus 3 times 10
plus 8.
plus 8. Well, we know that what's minus 3 times 10? Do you know, Charlotte?
Minus 30.
It is. It's minus 30 plus 8. And what's minus 30 plus 8? See if Charlotte can finish this for me.
Minus 38.
Ooh,
Oh, minus 22.
good. Yeah, so we're coming back up the number line, aren't we? Minus 22. So, with that formula, I can find any term I like in exactly the same way. I'm just going to be careful with my negatives. Right, does anybody else have another sequence, either with negatives or getting smaller? Either way, I don't mind. Anyone else have another sequence with negatives? Irana?
49, 44, 39, 34,
Good.
29 and 24.
Good. And that would eventually, wouldn't it, head into negatives as well? Eventually it would. Right, so what did you have as your formula for this then?
Minus 5n take away 1.
Ah, interesting. Minus 5n, definitely, because what's happening is we go from there to there, we're subtracting 5, so I definitely agree with that. But where does your minus 5 times table start, if indeed there was such a thing? What would be the first number in your minus 5 times table?
Minus 1.
Would it? It would be minus 5 times 1, wouldn't it? That would be the first number in your minus 5 times table. What would be minus 5 times 1?
Minus 5.
Thank you, Lord. Minus 5. If you think about it without the negative in, 5 times 1 is 5, isn't it? The negative just changes the sign of the answer, so it's minus 5. So my minus 5 times table starts at minus 5, but your sequence starts at 49. So how do I get from that minus 5 to that 49? What do I need to do? Do I need to add on or take off? Add. I need to add on. I need to add on quite a lot, don't I? How much do I need to add on? Not quite sure. Right, let's do a number line. I'm starting here, and I want to get all the way up to here.
54.
There you go. Plus 54. If you visualise something as a number line, you can see exactly what you need to do, can't you? And you can't always without. So always think about a number line, draw it. Is everyone happy with that? Can you see? Right, let's try one more. Anyone else got one with negatives or getting smaller? Anyone else got one? Matthew, did you have one?
Oh, yeah.
Go on.
-1, -3, -5, -7, -9.
Lovely. Right. So what did you have as your formula for that one?
-2m plus 1.
Right, minus 2n plus 1. Absolutely right. Well done. Good. Okay. So do we all feel reasonably comfortable now with finding these formulas? Yes? And we know how to use those formulas if we've got them? Yes? No? Yes? Say no if it's no.
Yes.
And say yeah, I don't mind. If it's no, tell me, because then I can do something about it.
Yes.
We're all okay?
Yes.
Yeah? Good. Right, that's all we need for this bit. Okay.